Welcome back to Planetary Possibilities. I'm Aria. If you watched our episodes on Diamond Rain Worlds and Mirror Worlds, you know we're building a catalogue of the most extraordinary planets that could actually exist. Today marks episode 3, and this might be the one that changes how you think about solid ground forever. Imagine standing on a beach. The sand feels solid, permanent. You look at the horizon expecting distant mountains, but instead, you see an entire continent, the size of Australia, gliding past you like a ship made of ice and stone. Behind it, another landmass, and another, each floating on an ocean so deep that Mount Everest dropped into it wouldn't even reach the surface. Today, ocean worlds with floating continents, planets where geography is temporary, maps expire like milk, and the ground beneath your feet is on a journey. And the science, it's not just possible, it's inevitable. Our first world is the Wandering Archipelago. What does it look like? From orbit, this planet is blues and whites, but the ocean is indigo, darker than Earth's, because the seafloor is 200 kilometers down, 40 times deeper than the Mariana Trench. Scattered across this global ocean are thousands of continents made of water ice, white, pale grey, luminescent. And they're not random. Ocean currents arrange them into vast circulating patterns, like cream swirled into coffee and frozen mid-motion. From space, you can watch these massive ice formations drift along invisible highways of current. How does this work? This world lives in a temperature sweet spot, cold enough that ice continents up to 50 kilometers thick stay frozen solid, but warm enough that the ocean never freezes over. These aren't thin ice sheets. They have mountain ranges, valleys, cave systems. The deepest parts extend hundreds of meters below the waterline like inverted mountains. And because they're not anchored to anything, ocean currents driven by the planet's rotation and underwater volcanic heat push them at 10 to 30 kilometers per year. That's faster than Earth's tectonic plates. Continental drift here isn't ancient history. You can measure it in your lifetime. Why is this scientifically possible? We've found the prototypes. Europa has a global ocean beneath its ice shell. Enceladus is erupting ocean water into space right now. The Wandering Archipelago just takes it further. Enough internal heat from radioactive decay and tidal forces to keep deep oceans liquid, but far enough from its star that surface ice stays stable. The physics is simple. Ice density, 0.92 grams per cubic centimeter. Water, 1.0. Ice floats. Scale doesn't change that. With over 5,000 exoplanets discovered, floating ice continents existing somewhere isn't just likely, it's practically guaranteed. But ice isn't the only thing that can float on planetary scales. Meet the Pumice Drifts. What does this look like? This world orbits a red dwarf. The oceans are liquid ammonia and water, eerie greenish-grey like tarnished silver. The continents are rust red, charcoal black, sandy yellow. They're made of ultra-light volcanic rock, pumice, aerogel-like minerals, and silica foam created by explosive underwater volcanism. Up close you'd realise they're more air than rock, riddled with billions of air pockets. Your footsteps would echo, like walking on hollow ground. And they sail up to 100 kilometers per year because these massive light continents catch atmospheric winds like stone ships. How it works: violent underwater volcanism across thousands of vents. But at 0.7 Earth gravity, with lower ocean pressure, eruptions are explosively different. They create massive amounts of volcanic foam that literally bubbles to the surface. Over millions of years, these foams accumulate into rafts, then islands, then continents, and they're constantly growing from below, new volcanic material adding to their underside, maintaining buoyancy even as surfaces erode. The wildest part? These continents collide. not slowly like Earth's tectonic plates, but fast. When they crash, they form temporary supercontinents with mountain ranges of compressed pumice. Then, within centuries, they break apart again. A civilization here would watch their continent collide with another in a single generation. They'd build cities that can move, adapt, or be abandoned entirely. Why is this scientifically possible? In 2012, a pumice raft the size of Belgium floated across the Pacific from one volcanic eruption. Scale that up, lower gravity making volcanic foam more stable, constant volcanic activity, and ammonia water oceans less dense than pure water. The chemistry works, the physics works. And with countless volcanic ocean worlds around red dwarf stars, the most common stars in the galaxy, the Pumice Drifts exists somewhere. So there you have it, ocean worlds with floating continents. From the icy archipelagos gliding through indigo seas to the volcanic pumice continents sailing on ammonia oceans, these planets aren't just theoretically possible. They're out there. Somewhere, there's a world where the ground moves, where maps are always expiring, and where entire continents drift like ships on an endless ocean. Thanks for exploring this with me. And if you haven't already, please go back and check out our previous episodes on Diamond Rain worlds and mirror worlds, because you don't want to miss out. Next time on Planetary Possibilities, we're heading somewhere even stranger. Worlds where they stare back at you. Eyeball planets. Yes, I'm serious. Worlds locked in eternal stare, half frozen, half burning, with a ring of twilight that never ends. And what might be living in that twilight zone will keep you up at night. Until then, I'm Aria, reminding you that the universe is more mysterious and incredible than we will ever realize.